Now let's know more about the antenna. You can see the antenna type. We have several types here. One is omni antenna, second panel antenna, sect antenna, and the dish and grid antenna. All the antenna now is available to sell to customer by Wisnetworks. Uh, we can see that we have different models which is using different antenna, especially for the sector, dish, and grid are very popular used for our product. There is a very important feature of antenna or parameter of antenna called antenna gain. Most people would think that antenna gain is something like radio power. It is the parameter showing that how strong the antenna or how strong of this radio. But I can say that antenna is a passive device. It doesn't generate the power, and it doesn't reduce the power. So an antenna has a higher gain, means higher performance at a specific direction. See, so it doesn't mean that the higher gain antenna means the higher power. In some direction, it would have a very strong signal, but in other direction, it may reduce the signal, very lower signal than common antennas. For example, you can see that this is a omni antenna, 3 dB. It is just like an apple, like a circle at each side. So the power is very average at uh, the 360 degree. If you look the 3D diagram from top to bottom, you see that like this, it is a very average power. But if you are looking to the panel 18 dBi antenna, you will see that it has very strong signal, very strong power at this direction, but at other direction or at the back of the antenna, it has no signal. So from these two diagrams, you can see that antenna just changed the signal shape, not increase the power. There's better signal area and there must be lower signal area, like this. Here signal is very strong, but this side signal is very low, even lower than 0 dBi. Okay, so we know that antenna gain is not simply a parameter like power, but it is only a feature that means how strong at a specific direction of the signal. Here we have some example for better understanding. An omni antenna, just like a light bulb, spread the energy to every direction. It is omnidirection, everywhere. But for directional antenna, especially for high gain antenna, it is like a spotlight. It focuses all the energy of the light to a specific direction or specific area. We can see that omni antenna often used for the client device or indoor radios. It need to ensure that receive or transmit the signal at every direction. But directional antenna, it is very suitable using for point-to-point and point-to-multipoint applications, because only that point, only that direction needed the signal. So it would utilize the power to that direction to make sure that that direction would have the best power of the signal. And the sect antenna is a special kind of directional antenna. It can also called a directional antenna, but it have specific degrees of the direction, like 90 degree for a sector area means that all the devices in that area can get the signal. But except that area, there is very low signal. So the sector antenna mostly used for point to multi-point connections. Another parameter of the antenna is the VSWR. It is also used to evaluate the efficiency of the antenna. You can see this diagram that means how antenna works. If we input some radio power to the antenna, we must have some output power through the antenna. But they would also have some power reflection back to the radio. So the best antenna can make all the input power to output, but it is only theoretically. All the antenna now selling on the market would have some power reflection. So VSWR, the voltage standing wave ratio, just means how low of the power reflection. The value of the VSWR, the lower the better. So you can see 1.0, the reflectivity is only 0%. Okay. Most antenna we are using now is from 1.5 to 2.0. It means that less than 11% of the signal would have power reflection back to the radio. And there's an important concept of the VSWR is that it is not a stable value. Means like this diagram, you see that from 5.0 gigahertz to 6.0 gigahertz, it has a curve showing that the VSWR. Some of the frequency would have better VSWR like 1.2 or 1.3, but for some other band of the radio, it will have 1.8 or more than 1.8 of the VSWR. All Wisnetworks radio and antenna VSWR is lower than 2.4, so it is qualified to using every outdoor applications. The polarization is the last important parameter needs to be clarified in this course. We know that radio is generated by moving electric, so different moving direction of electric field would change the radio wave form. In 11A BG period, all Wi-Fi system using single antenna, so only vertical polarization is required because horizontal polarization wave would be more easier to be absorbed by the Earth's ground. If you have a vertical polarization radio to receive horizontal polarization wave signals, just like this picture, the signal strength would seriously decrease, just like the picture showing. You see, that is, have no energy anymore. So we can get one great information from this example is V, that means vertical, H means horizontal. V and H polarization wave have good isolation features. They are isolated. They are not interfere to each other. So it is just like different frequency. Here in this picture, you see that a vertical wave, like a vertical transmitter, using a vertical receiver, the power can get the power. Okay, so a horizontal transceiver in a transmitter in a vertical receiver, when they are using together, the power lost. Okay, so according to this point, the 2.2 MIMO wireless system using dual polarization antenna is reasonable and easy to understand. V to V, H to H, not H to V. Okay, here is the example of our CPE antenna. This is the horizontal antenna, and this is the vertical antenna. Okay.